We'll now continue section 8.2, and we're going to start discussing polar equations. So we're going to begin with an example. Our example asks us to rewrite the equation x squared minus 2x plus y squared is equal to 0 in polar coordinates. Because the equation has x's and y's in it, we know that the equation is currently in rectangular form. We need to change it into polar form, meaning that we need an equation that has r's and thetas in it. So we're going to use our equations. X is equal to r cosine theta, and y is equal to r sine theta. So we're going to take our equation, x squared minus 2x plus y squared, and we're going to substitute in for the x's and the y's. So if there's an x, we're going to enter in r cosine theta, and if there's a y, we're going to enter in r sine theta. So I'm going to write my equation down as it is, and then we're going to make those substitutions. So in place of this x, we're going to put r cosine theta. The x is squared, so we're going to square that substitution. Minus 2 times x, so we're going to substitute in again r cosine theta for the x, plus y squared. And for the y, we're going to put in r sine theta. And again, that quantity is squared. Once that's done, we're going to go in and simplify what we can simplify. So this r cosine theta that's squared, let's go ahead and distribute our squared through that parenthesis. So we're going to have r squared times cosine squared. This one, we're going to have 2r cosine theta. And for our last term, again, squaring through the parenthesis, we'll have r squared and then sine squared theta. So the next thing I'm going to do is take the terms that are like terms and write them next to each other. So I have two terms that have an r squared. So I'm going to put those together. So I have r squared cosine squared theta, and I have a positive r squared sine squared theta. And then we have this 2r cosine theta that kind of sits by itself. In looking at my first two terms, I notice that I have an r squared that's common. So I'm going to go ahead and pull that r squared to the front, factoring it out. So if I take an r squared out of an r squared cosine squared, that's going to leave me a cosine squared. And if I take an r squared out of an r squared sine squared, that's going to leave me a sine squared. Now, note that the part in parentheses, the sine squared plus the cosine squared, is an identity that we have that's equal to 1. And so we can go ahead and say that this is going to be the same thing as 1. And let's finish it up. So we have r squared times 1, which would just be r squared. And then we have our last term, 2r cosine theta. Now keep in mind that we're not trying to solve this equation, we're simply trying to write it in terms of r's and thetas, which we've done, and simplify it as much as we can. Okay, let's try one more example like this. Our next example asks us to rewrite the equation 2r is equal to secant theta in rectangular coordinates. So currently our equation is in polar form because it has an r and a theta, and we want to write it in terms of x and y. So again, what I want to do is I want to think about my formulas for x and y. X is equal to r cosine theta, and y is equal to r sine theta. Now, the thing that I notice is that in neither one of these formulas do we have a secant. And so my first step is going to be to take that secant and rewrite it in terms of either a sine or a cosine so that it'll come a little closer to matching up with one of my formulas. We know that secant and cosine are reciprocals. So secant is the same thing as 1 over cosine. Now, the next thing I'm going to do with this is I'm going to multiply both sides by cosine. That'll take care of my fraction. And so on the left, I'm going to have 2r cosine theta. And on the right, the cosines are going to cancel, leaving me 1. Now, what I notice is that this r cosine theta is the same thing as x. And so I'm going to substitute that in. So I have 2x is equal to 1. And if I divide both sides by 2, I have x is equal to 1/2. So we now have an equation that has been simplified in terms of x's and y's. So we have converted the polar equation that we started with into an equation in rectangular form.